Hello everyone and welcome to another video on building serverless Java applications on AWS. In this video, we're going to continue right off from where we left in the last video talking about SnapStart for Java. Now, if you remember from the SnapStart video, and if you haven't seen it, I'll put a link in the description for you. The SnapStart is enabled when a new version of your Lambda function is published. And when we publish versions of Lambda functions, we also have this concept of aliases. And that's exactly what we're going to dive into in this video, and probably the next couple of videos, is how you can use aliases and versions alongside SnapStart in your CI/CD process when you're using AWS SAM. So if you remember, we have this production alias here, and the production alias is the only one we have. And 100% of the traffic of our alias is sent to version 48 of our Lambda function. And version 48 is the latest version. It's been a little while since I worked on this, so it's 20 days since that was last processed. Now, we can use AWS SAM to configure how these aliases and versions work. So let's flick over to our IDE now, and we'll start in our SAM template because there's a couple of additional things I've added in here to enable this. And the first is I've actually added a couple of CloudWatch alarms to this template, and I've created two alarms, one on any 500 errors against my Java Spring API, and the second for 400 errors against my Java Spring API. And these alarms are what we can then use to control the deployment of our Lambda function. These metrics named 4xx error and 5xx error are built-in metrics to API gateway. So if we flick over to the AWS console now and I go off to CloudWatch and we look at our metrics in CloudWatch, if I come into API gateway, we can see we've got a couple of 5 built-in metrics here for 100 errors, 500 errors, latency, the number of requests, etc. And we can use these directly in our alarms. So here we're creating a couple of CloudWatch alarms. I'll put some links in the description to the configuration of CloudWatch alarms. If we actually have a look at our Lambda function now and the way our function is defined, when we did this previously, we'd already defined that we wanted to automatically publish our alias for production, and we've also enabled SnapStart as well. You see we've enabled SnapStart on our published version. And what this will do, this tells Lambda and tells SAM that when we publish a new version of our Lambda function, we want to auto-publish that to our production alias. Now, the new thing that has been added as part of this video is this whole deployment preferences section here. And this is where we can control that traffic shifting. So as a default, if I was to remove all of that section, as soon as a new version of my Lambda function gets published, all of the traffic will instantly be shifted to my production alias. That will happen straight away. But we can use this deployment preference to control how our deployment happens. So one of the options available is all at once, and you might do that in your development environment just to get the changes out quickly. But what we're actually going to use here is this canary 10% 10 minutes option. If we just open up the documentation for SAM, these are the available options built in out of the box. And how these kind of differ, obviously all at once is quite clear. It'll shift everything all at once. What these canary options will do will shift 10% of the traffic to your new Lambda function straight away. And then n number of minutes later, in this case 30 minutes later, it will shift all of the other 90%. That differs slightly from the linear option, where the linear 10% every 10 minutes will shift 10% of the traffic to the new version every 10 minutes. So after 10 minutes, it'll be 90-10. After 20 minutes, it'll be 80-20, and so on and so forth. So they're the options we have out of the box. So for the purposes of this example, we're going to use canary 10% 10 minutes. And the really useful thing we can define in this deployment preference is this alarms section. And we can pass in a set of CloudWatch alarms to tell the deployment that if either of these alarms error or move into an error state, then we want to roll back the deployment. And we'll see this in action in just a moment. So what this total configuration is saying that when I deploy a new version of this Lambda function, it's going to shift 10% of the traffic to my new version straight away. And then 10 minutes later, it will switch over the other 90% unless I get a set of 500 or 400 errors against my API. Now, to see this in action, I'm actually going to need to make a change to my API to actually get a new version of my Lambda function to go out. And what I've actually created is this error controller to actually force an error in this API. So I'm just going to change this pretty trivially. I'm just going to make myself error. Just going to change that log message there. That will then cause a redeployment of the Lambda function. And if I flick over to my terminal window now, we can actually create a redeployment of this. So if I just navigate into my directory, I'm in the same direct directory as my SAM template now, and I'm first going to run a SAM build to actually compile my application and generate the SAM template ready to be deployed. And that's completed now, and I'm then going to run a SAM deploy to actually deploy a new version of this Lambda function. And now there's a couple of stages that are going to happen here. The first thing that's going to happen is the new version of my code is going to be uploaded to S3. And then a new version of my Lambda function is going to be created. Now remember, because we're using SnapStart, that new version creation process can take a couple of minutes. So you can see here we're getting a CloudFormation change set generated by AWS SAM. Our new change set is going to create a new version of my Lambda function, and then it's going to modify the alias of my Lambda function. And this is where it's going to take the traffic from the existing version and move that over to the new version. So if we go back to the AWS console now, if I just find my console window, and if I just refresh my console window, we will now see this in action. So if I go to my versions tab, you can see I've got a new version straight away. I've got version 50, look in there, modified 23 seconds ago. And if I actually go into version 50 now, I will get this quite handy message up at the top here that's basically telling me that SnapStart is going to add a few minutes to the version creation process. Because if you remember, at this point, the initialization phase of the Lambda function is running, our Spring API is starting up, and then a snapshot of that execution environment is going to be taken, ready for actual requests to come in. So I'm just going to pause the video here while the SnapStart process completes, and then we'll come back and look at the traffic shifting. Okay, so the SnapStart version has now been created. So we now have version 50 of our Lambda function. And if I come back to the actual Lambda function itself now and we look at the aliases, you can see that 90% of our traffic is being targeted at version 48 and 10% is being targeted at version 50. And if we actually flip back to our terminal window, we can see that same thing. So we can see the update of the alias is in progress, and it's using code deploy behind the scenes to actually perform that deployment. Now, what I'm going to do to demonstrate this in action is I'm actually going to take my API endpoint, which I've got over here in another window, and I'm actually going to run some requests against this API endpoint. So we've got our product API endpoint, which is just going to list all of our products, of which there aren't any at the minute. And then what I'm actually going to do is I'm going to force some errors in this endpoint. So if I navigate to my error endpoint, you see I get a 500 error. If I just go to some random endpoints, so I've got a 404 there, and I'm just going to hit this endpoint a few times now just to generate some 404 errors. I'm going to pause the video while I do this, but I'm just going to refresh this a few times now just to get some errors into the metrics that will then force that rollback to happen. So I've just been hitting this API endpoint a few times now, and if I go back over to CloudWatch, we can see that we've now actually got both our alarms in error. And that's because our 400 errors, so we had 77% of our total requests with 400 errors in the first set of 30 seconds, and then 44% of our requests in another 30-second window. And the same for our 500 errors. we got quite a small number of 500 errors initially, and then we got a slightly higher number of 500 errors in the second 30-second window. And if we flip back to my terminal window now, you can actually see that this failed to deploy. So we're getting the messages back in CloudWatch to tell us that this is exactly what has happened. It's failed to deploy. Now, one of the really useful things about this is when this does actually fail to deploy, is that that version doesn't get deleted. Remember, these are two very distinct phases here. The version gets created, then the traffic gets shifted. Now, what that means is that we could actually now come in here and create a new alias. So we could create an alias saying, deployment fix, for example, and we can point that at version 50, and we save that. And we've now got a new version of our Lambda function. So we've got this deployment fix alias against our Lambda function, pointing at our version that's just failed to deploy. And we can then use that to do some debugging. So I can actually come into here now and I can make an API request against my API. Of course, this is going to return a 404 error because I've not actually passed in an actual path. So it's actually quite useful that you get these two distinct phases of deployment. You get your SnapStart enabled version, then the traffic gets shifted. So that's a really quick introduction to aliases and versions. And in some of the next videos, we're going to look at some of the patterns and some of the other things that you can put in place to really help enable this CI/CD process. Things like leveraging step functions to actually generate some synthetic traffic against your API to ensure that even when you're doing the deployment and there's no traffic, that you're still getting enough traffic to ensure that that successful deployment happens. And also using the pre-deployment and post-deployment hooks to actually do things after the version is created, but before the deployment is started. That's all for this video. As always, if you like this, please like, please subscribe, please share, and I will see you next time for more serverless Java fun. Thank you for watching.